Let's continue our look into some basic heat treating or hardening and tempering issues and ways to determine if your found piece of steel is worth your trouble to make some sort of a tool out of. This is a piece of a bolt of some sort that has a nut on both ends that holds giant wooden spools together. This is a smaller spool, but somebody gave me a whole bunch of this stuff, and I've got this from probably 5/8 diameter, and this is about 5/16 diameter. So the question is it some sort of hardenable steel that maybe would make good drift pins for making hinges or some other small tools like that, or maybe little chisels, although I bet it doesn't harden that much, but we'll find out. Or is this something that I can use just like I would mild steel for making hooks and hangers and other things like that out of, because it won't get hard and brittle. Since it's a found steel, I have no idea. So I need to do some testing. In our last video, we spark tested it, and it doesn't spark test like any known steel that I have on hand to compare it to. It spark tests like it has some alloy in it, so I wouldn't be surprised if it's something similar to 4140 but with less carbon, so maybe it's a 4120 or 4130, I don't know. No idea, and we'll never know for sure, but we can find out a little bit more about it. And to do that, we're going to test harden it. And that's one reason I chose a piece of 5/16 round bar instead of something bigger. If you've got a big piece, if you're doing an axle shaft or you're doing some other monstrous piece of steel, draw out a small piece. This technique works best in smaller sections. You want something that typically you can bend cold. And I'll show you why that might be important here in just a little bit. So the first thing we're going to do is get it hot. To harden steel, you have to get it above what they call critical temperature. And we'll talk about critical temperature a little bit more in another video, and exactly what that means and why the common way of testing for critical temperature might not be the best. But for our purposes today, we just want to get it good and hot. So if we get this into the orange range, it'll be above the critical temperature most likely. Unless it's H13 or S7, it'll be above the critical temperature. But probably it isn't. So anything over about 1600 degrees is probably higher than the critical temperature, and it will tell us if it's hardenable or not. And that's all we need to know in our test hardening. And we're going to do this 3 times. So first I need to get it hot. For practical purposes, there are essentially 3 different ways you quench steel or cool it to harden it. To harden steel, it has to undergo a transformation at high temperature, and then you have to freeze it at that transformation point. And we'll discuss the terminology and what's happening to the crystalline structure of the steel in future videos. I don't really want to confuse that for what we're doing today. The classic is you heat it up till it's not magnetic anymore, and you quench it in water, and you're good to go. That's not really the case for most modern steels anymore. Neither one of those things is really correct. So I've heated this way beyond the magnetic point, and the first thing I'm going to do is quench it in air. Air is our easiest, lowest stress quench medium. And you just let it cool. And you let it cool till it's cool enough that you can keep your hand on it. Something around 150 degrees is probably ideal. And then we'll do a couple of quick tests to see, is this an air hardening steel? If it isn't an air hardening steel, we'll go on to the next quench medium. Now we've let this air cool until we can touch it. Notice how I test this though with the back of my hand. Your natural reaction if you come in contact with something you shouldn't touch is to clench and do this. So if you grab and test for heat this way, you might accidentally grab the piece that you just determined was way too hot to grab. So if you do this, you pull away from it. And also that means if you do burn yourself, you burn the back of your hand instead of the palm of your hand, and you'll still be able to hold a hammer for the rest of the day because you're not getting out of work that easy. But anyways, we've air cooled this. This, if it's air hardening steel, this is as hard as it should ever get. So did it get hard? How do we decide? One good way to do that is with a file. And find a place you can hold it. A vise is probably the best. And this files quite easily. So is that hard? No, that's not hard. And probably I don't need to go any further, but I want to have some references for my next test. I want to see, will it bend? Boy, it bends just fine cold. So it's not the least bit hard, bends easily. So what do we do now? Well, we tried air. We know it's not air hardening. Our next quench medium we would go to is oil or a polymer. And I've never used polymers. I use oil. And the oil that I use is a commercial heat treating oil. A lot of people use olive oil or canola oil, something like that. And I've heard lots of good things about that. It probably is not a bad idea. It certainly wouldn't stink as bad as this stuff does. But this is what I have, so it's what I'm going to use. Old motor oil has a lot of impurities in it. And if you're making tools that need to have certain properties, those impurities might change those properties. And you probably don't want them in your tools. So old motor oil is not a good quench medium. There are other oils that people use, and we'll discuss that at some other point. But the main thing is, it doesn't harden in air, so let's heat it up again and test it in oil. So let's quench this in oil, but first let's take a quick look at how I have my oil prepared here, or how I have it stored more importantly. I keep my oil in a metal bucket, and that metal bucket is down inside a bigger metal can, which is a rag can with a spring-loaded lid. I take my foot off of the pedal, it closes. So if I get a flash fire quenching stuff, I just pull the stuff out, let go of the lid, and it puts the fire out for me. I don't have to worry about it. But you should also have a fire extinguisher handy when you're quenching in oil. We're going to quench it in oil, and when you quench in something like this, keep it moving. In air it's not so important, but in the oil or water quenchers it is important because you get bubbles. As the oil sizzles and boils and does that, you get bubbles that insulate the steel and it doesn't cool properly or evenly, and that's one of the things that causes warps. So there again, when we think it's cooled down, we can test it. I'm not going to touch it too quickly here because if it's not cold, it's got hot oil on it, and I don't want to fry my fingers. So that's cooled off enough, we can now test it. So the first question is, can you file it? And yes, I can file it, but I can tell that files with more difficulty than it did the last time. Now that brings up a good point. It would probably be better to cut this in 3 pieces to do the tests and leave the air hardened one where you can compare it side by side and go back and file each one to the oil and then to the water, and that way you can see exactly how they're behaving instead of trying to remember. But based on what I recall from filing that is not as easy to file as the previous one. Does it bend any easier? Or any harder, I should say? You know, it's hard to say. That bent pretty easy. I don't think I bent it over as far as fast as I did the other one, so perhaps it's a little bit harder, but not a lot. So what does that mean? That means it's probably not an oil hardening steel. So let's test it and see if it's a water hardening steel. Now, if water doesn't work, you could go a little more severe, and there are more severe quenches. But for my purposes, I figure if it's not air, oil, or water hardening, it's probably not something I need to worry about for tool making, so it's not that big a deal. But let's test this and see if it hardens in water. So our next quench is in water, and I'm just going to use my slack tub. If this is really a critical component, fresh, clean water is much better, for the same reason that used motor oil isn't the best idea. Again, I'm going to move that in a figure 8, and I'm going to move it up and down, and I'm going to try and get it nice and cooled off as fast as I can, which is nice and cool. Handle end's kind of warm though. I've gone in for a little bit of a wardrobe change at this point. Now I've tested this stuff before, and I knew it wasn't going to air harden and oil harden. I'm just showing that. But just in case it really water hardens and it gets brittle, when we test bend it, it could shatter. And to prevent injury, I'm going to wear heavy gloves, the leather apron, and a full face shield. And that way, if it shatters, it won't be a big deal. I've never had one do that in doing these test procedures. They usually either don't break or they crack and they just fall on the floor. But the risk is there, so instead of having shrapnel flying all over the shop, do protect yourself. Again, our first test is just to file it. I don't know if you can hear that or not. That files, but it kind of skates a little bit. It doesn't file easily. It doesn't really want to file. It's going to be work. So it's certainly way harder than it was after air quenching, and harder than oil quenching to notice it. I got 2 left-hand gloves. So the next thing we want to do is give it a test to see if it will bend, break, or shatter into a billion pieces. Now that was a little bit tougher to bend, and it didn't bend quite as far, and it was harder to file. So it certainly is harder after water quenching. So it's got some sort of a carbon content in it that allows it to harden. It's more than just mild steel. You'll also notice it bent clear back here because of the leverage on here. It didn't just want to bend because this is tougher. Back here where it hasn't been hardened is where it kind of wanted to bend. So that might have some application for something, I don't know. For me, I'm going to reject it for any kind of a tool use because it simply isn't hard enough. If I just needed a quick drift pin, that would probably work. But other than that, I'm not sure that I would use this for anything. Now there is one other level of quenching that you could do after water. You could go to brine, which is salt water, and that's enough salt dissolved in the water that it will not dissolve any more salt. And I don't keep brine around because I generally don't use it, so we're not going to go to that step. But my guess is this would get a little bit harder again. But I don't think I need to worry about this for too much. I've learned what I need to learn from this. And this procedure is what you should go through with any of your unknowns. Do the test hardenings and at least know if it's air, oil, or water hardening steel, or if it doesn't really harden at all. That tells you a lot right up front. Now it doesn't tell you what the critical temperature is. It doesn't tell you how hard it really is, although the file is a fairly good relative indicator. Nor does it tell you what the tempering temperatures are. Those are all more experimentations that you're going to have to do, and you're going to have to make things out of it and try them out and say, well, that didn't work very well, or that worked great. What did you do? Keep notes. Anyways, I hope that explains test hardening in air, oil, and water to see what type of steel you might have or what hardening medium that steel wants. I hope you found it useful. Give it a thumbs up. Love it to hit the subscribe button. Share the videos with your friends if you think they'd find them interesting. But make time in your day to get out to the shop, make something, learn something about blacksmithing, about how your material behaves. But do stay safe. Do wear your safety glasses or a full face shield if you need it. And we'll see you for the next one.